Hello guys, this is Joy again, and we are moving to part 5 in SURD, and we are making progress, and I believe we are also following. That's part 5. Part 5. We're dealing with addition and subtraction. Uh am I correct with this? Okay. Addition and subtraction. Subtraction in SURD. Addition and subtraction in SURD. So if you remember what I said in part 3 of my video, I said, if you remember what I said in part 3 of my video, part of the condition that's valid and invalid, at either part 3 or part 4, valid or invalid, I said A plus B is not equals to, as in square root of A plus B is not equals to square root of A plus square root of B. Okay, now the condition behind addition and subtractions in SURD is that they must have they must be of like sort before you can add them. What did I mean? So the meaning of like sort is that like sort must be observed. Like sort must be observed before you can add or subtract in sort. What I mean by example, what I mean by like sort is that if you have a square root of b, you can add it with c square root of b. That is the meaning of like sort. So that is example number 1. Example number 2, if you have, let's say, m square root of c, you must have, before you can add them together, you must have, let's say, n square root of c. So what is the like sort that I'm talking about here? I'm talking about these and this. Okay, that is the meaning of the like sort that I'm talking about. These are like sort. Like sort. So this can either be plus or minus. Like what I'm trying to say here is that, just to save our time, this can either be plus or minus. That is, I can say a root b minus c root b, or I can also say a root b plus c root b. Either of the two, either of the question can come up. So before you can do addition, which is this, or before you can do subtraction, which is this, they must be of like sort. So this is an example of like sort. So it means B must be common before you can add them together. The same thing applies here, plus or minus, which shows that C must be common before you can add them together. So that is what we call like sort. So before you can do, that is the condition I made mention in my part 3 or part 4 presentation. So it means that they must be of like, that's the condition, like sort. So I hope the like sort is clear now. And the plus or minus I put here is that the question can come in form of subtraction. Okay, it can also come in form of it can come in form of addition. So if that is clear, let's now pick an example that we can work with so that it can be more clearer to us. So now if you look at it very well, let's say, see, in mathematics you can think of example in as much you understand the basic. Okay, I've said this before. So let's say example 1 now. Example 1, that's example, we're talking about, okay, let me say 3 roots 7. Okay, I will say plus 4 roots 7. Now, because this is the like sort that I'm talking about, if you look at this very well, this is the like sort, this is the like sort, this is the like sort that I'm talking about, like sort, like sort. Okay, so it means that I can add them. So what do I need to do? I pick one of these, which is equals to, what is 3 plus 4? 3 plus 4 is what? 7. Then 7 is common. I pick 1 root 7. Very simple. Do you see it now? That is how you can add in SURD. Okay, you can only add because we have like SURD here, which is root 7 and what? Root 7. Let me give you another example. That is number 2. Let me say I have maybe 9 roots. Let's say 9 roots. Let's say 9 roots 11. Okay, plus let me just say maybe 5 roots 11. So what do I mean here? If you look at this very well, this is an example of like sword, they are the same. So because they are the same, you are going to add it together. But if they are not the same, you cannot add it together. So 9 plus 5 will give us what? 14 root 11, which is fantastic. So it's very, very straightforward. The same thing applies to when you have subtraction. If you look at this one very well now, let's say number 3 now, we're dealing with subtraction. I'll just say, okay, let me say 20 roots, let me say 20 roots, 20 roots, should I use the word, let me just say 20 roots, 3, okay, and then minus, that's let me just say let me say 14 root 3. So from this now you can see that it's very, very simple. I can say yes, this root 3 that you see here, they are what? Like sort, like sort. Okay, then I can go ahead and subtract 20 minus what? 14. So 20 minus 14 will give us, that is that's 6 root 3. It's as simple as that. That is what we call addition and subtraction. Let me give you another example on subtraction. I can come here and say, oh yes, fantastic, I wanted to do another subtraction now, and say, okay, yes, I have, let me say, 5 root, let me just say, what can we use now? 11, 12, 13, 14, 15, 16. Let me say 17. 5 root 17. Let's say minus, let me use 2. Let me use 2 root 17. This, so now because this is like sort, root 17 is common, I can subtract. So 5 minus 2 will be what? 3 root 17. So it's as simple as ABC. Okay, so this is what we call addition and subtraction in SWORD. So in part 6, what we're going to do in part 6 is for us to now get as many questions as possible, okay, on either simplification, on either single sword, okay, on either. So I'm also going to share maybe a written what's it called now, a written assignment that you will show to you. Go and look at it and solve as many as possible, so that at the end of the day you'll be able to get used to how you can solve swords in in mathematics. Okay, so after this part now, the next part will ensure that we share that with you. Please ensure to like, please comment, and then also share the video, so that people can benefit, they can also learn and see how simple this topic is in mathematics. Because as simple as it is, it comes out in essay, either in their objective or in their theory part. As simple as it is now, it comes in schools also, they give you in the exam, and also in the past question in the jam, or it comes out too, very as simple as it is. So it is good that we play around with a lot of questions around this part, and I'm very sure that um you'll be able to perform very well by the time we're done with all the topics in mathematics. So thank you very much.